My name is Mehak Askar. I am from chemistry department. Today the topic of my presentation is selenium. So let's start the contents, which includes introduction, history, properties, characteristics, sources, abundance, isotopes of selenium, uses of selenium, its harmful effects, and reference. Introduction. Selenium is a non-metallic chemical element with symbol Se. Its atomic number is 34. Selenium is solid at room temperature. History. Selenium exists in only trace amounts around us. It was discovered by John J. Berzelius in 1817. Martin Klaproth, the discoverer of uranium and zirconium, had concluded that a red-colored byproduct of sulfuric acid production contained tellurium, an element whose compound he had been studying. Berzelius analyzed the sample and decided it did not contain tellurium, but in fact contained a new element similar to tellurium. Since he named the new element selenium. The name is derived from Selene, the Greek name for the moon. Properties. Selenium is found in various forms ranging from a grey metallic to a reddish glassy appearance. It is also found in various rocks and minerals, coal and oil. Its melting point is 494 Kelvin or 221 degrees Celsius or 430 degrees Fahrenheit. Its boiling point is 958 Kelvin, 685 degrees Celsius and 1265 Fahrenheit. Its density is 4.79 gram per centimeter cube at 20 degrees Celsius. Its atomic mass is 78.96 gram per mole. Its heat of fusion is 6.694 kilojoule per mole. Its heat of vaporization is 37.7 kilojoule per mole. Characteristics. Selenium exists in several allotropic forms. The most stable crystalline hexagonal selenium is metallic gray. Crystalline monoclinic selenium is a deep red color. Amorphous selenium is red in powder form and is black in vitreous form. Gray crystalline metallic selenium conducts electricity better in the light than in the dark, photoconductive, and it can convert light directly into electricity, photovoltaic. Selenium combines with metals and oxygen to form selenides such as zinc selenide, selenates such as calcium selenate, and selenides such as silver selenide. Allotropes of selenium. Top one is amorphous black selenium, middle metallic gray selenium, and bottom amorphous red selenium. Sources of selenium. Selenium is occasionally occurs free in nature, but more often occurs as selenides of iron, lead, silver, or copper. Commercially, selenium is obtained mainly from the anode mud waste produced in the electrolytic refining of copper. Brazil nuts are the richest known dietary source of selenium. Selenium from anode mud. Anode mud is mixed with silica and soda ash after the removal of copper. This mixture is then melted. The slag contains various metallic impurities such as iron and silica, which are removed. Air is forced to the molten char to produce volatile selenium oxide, which can be separated from the solid residues. Selenium abundance. Abundance in Earth crust. 50 parts per billion by weight and 10 parts per billion by moles. Abundance in solar system. Parts per billion by weight and parts per billion by moles. Isotopes of selenium. There are 30 isotopes of selenium. Selenium has 6 natural isotopes that occur in significant quantities, along with the trace isotope selenium-79, which occurs in minute quantities in uranium ores. 5 of these isotopes are stable: selenium-74, selenium-76, selenium-77, selenium-78, and selenium-80. Abundance of isotopes of selenium. The abundance of selenium-74 is 0.9%, selenium-76 is 9.4%, and selenium-77 is 7.6%, selenium-78 is 23.8%, selenium-80 is 49.6%, and selenium-82 is 8.7%. Uses of selenium. Selenium is used in the glass industry in the form of sodium selenate to decolorize glass and to make red-colored glasses or enamels. For example, adding a little selenium has been shown to remove the green tint imparted by the presence of oil impurities in soda lime silica glass. It is used as a catalyst in many chemical reactions to prepare elemental sulfur bisulfite reaction. It has the advantage of stable structure and performance, which can be recycled and used repeatedly, simple processes and equipment, low production cost, no environmental pollution, and so on. Selenium is used in solar cells and photocells. In fact, the first solar cell was made using selenium. Selenium shows high absorption coefficient and mobility, making it an attractive absorber for high bandgap thin film solar cells. It is also used as a photographic toner. Selenium toner enhances a print's tonal range. It can produce tones from red brown to purple brown depending on the dilution. Selenium tone prints are highly stable. Despite its toxicity, selenium is also a trace element in the animal and human diet. It has a Goldilocks like quality that you must not be exposed to too much or too little of it. You must get the right amount. Functions of selenium in our body: protects our cells against damage from free radicals, supports our immune system, grows and keeps healthy muscles, support our thyroid function, and supports our reproduction. Harmful effects: selenium is considered to be toxic if it is taken in excess. It is carcinogenic and teratogenic. Seleniates and selenides are very toxic, and hydrogen selenide is an extremely toxic corrosive gas. Selenium toxicity can occur with acute or chronic ingestion of excess selenium. Symptoms of selenium toxicity includes nausea, vomiting, nail discoloration, brittleness, hair loss, fatigue, irritability, and foul breath odor, often described as garlic breath. Reference: Francis William Aston, Lantec, Periodic Videos, and Wikipedia. Thank you.